to another one of CTS's educational videos. This time I'm joined by Carlos Fernandez, and we're going to be talking about mission critical push-to-talk and mission critical communications in general. It's a very exciting topic area, and I think you're going to find this a very interesting short session. Next slide, Carlos, please. So a little bit about CTS. If you're not familiar with us, we are one of the largest wireless systems integrators in the country. We've got over 19,000 projects. Our artists gave up trying to put all the dots on the map. But what's important here is our 15 offices spread around the country where we provide coast-to-coast capabilities for design, construction, and managed services for private wireless networks. Next slide, Carlos. We've been fortunate to work with some big names in the industry and also very small operations. So we have the capability to do the largest Super Bowl stadium or a single retail store with our end-to-end design capabilities. And on this next slide, you can see that when we look at private wireless networks, we look at it in a holistic fashion. We can design any type of building and any type of private wireless network, be it 4G or 5G, indoor or indoor-outdoor combination campuses with our design center out of Phoenix, Arizona. Then we bring our nationwide construction team into play, and they can build any type of wireless network that's appropriate for the particular customer. And then we provide ongoing managed services. So we run LTE and 5G core networks, either on-site with our customer as a managed service or in our cloud data centers as a completely outsourced service. Or what's very popular is a hybrid service where we have portions of the core network at the customer site and portions running in our cloud, which provides a very effective and cost-effective solution. And then after the systems are up and running, we provide 24/7 monitoring with our very advanced artificial intelligence-based monitoring systems and platforms and our team of professionals watching over our customer systems. So private wireless networks are growing throughout the U.S. And a lot of that growth is based on interesting and powerful applications that run on top of that wireless network. And that's why I want to introduce Carlos to bring the TASSTA story to you on how mission-critical push-to-talk and mission-critical communications in general are so important to so many industries and how they blend perfectly with these private wireless networks. So Carlos, why don't you take us away?
So hello, Dean. A pleasure to be with you today and the audience. So yes, I'll try to explain, how TASSTA's mission-critical push-to-talk solutions, on top of private LTE networks, are a really, really good combination and can help build a truly mission-critical service for our customers. So TASSTA, first of all, is a company headquartered in Germany. Our offices in the US are in South Florida. So we've been doing mission-critical push-to-talk over broadband since 2012. And our software or application that works in mobile devices such as Android, iOS, Windows, or Linux, together with our full console dispatch solution, provides our customers an alternative to the legacy traditional land mobile radio networks. Of course, we understand that those customers, when transitioning from traditional radio to private LTE, they'll still have some needs during the migration to connect both systems, both networks, or both solutions, however you want to call it. So we've also developed, as part of our product portfolio, a very comprehensive suite of gateways that will help our customers to basically interconnect both the broadband and the narrowband worlds while migrating. I'd like to give you a 1 minute what's mission critical push to talk, because mission critical push to talk is widely used in the industry, and but not really strictly sometimes. So the 3GPP, which is the same body that standardized LTE and is working with 5G now, also has some groups that created a standard for mission critical push to talk over LTE networks. So that's called generally MCX, and the X is because, of course, there are 3 flavors to mission critical services over LTE, which is MCPTT, that deals with mission critical push to talk, MC Data, that deals with data transmission, like text messaging, GPS, and MC video that will deal with real time. So this standard not only covers how an application should be developed, but also covers how it should be interconnected to a private LTE core or public LTE core, basically with quality of service, and also how devices should be built so that they can comply with the mission critical push-to-talk concept. So in TASSTA, we have one thing in mind. Of course, we've developed the application, but one key thing is that it has to be user-friendly. So we cannot have a professional user that is in an emergency situation having to navigate through different screens of the smartphone to be able to make an emergency call. So we took that really seriously, and you're going to see later our application is really user-friendly and is really geared towards critical customers. This is a bit of an outline of what I'm going to try to show you in a few minutes about what the TASSTA mission critical application does. I mean, we're going to go from the basic voice functionalities, going through mapping and location. We're going to talk about video as well. We're going to talk about encryption, security, and finally, I'm going to try to do a short demo on lone worker protection and man down, which is really demanding in the, for professional users. So first and foremost, voice. So what can we do with voice? What should an application have to deal with voice, so to be called mission critical? So of course, we need to offer group calls. So all our users, can have multiple groups and they can all talk together, and it's going to be regulated by PTT, of course. So those groups can have different priorities because we can handle different priorities where dispatcher is a higher priority. Supervisors can have a higher priority so they can preempt when somebody is keying on a certain channel. So we also developed individual calls. So individual calls, they have two flavors, either half duplex, which is PTT driven, or full duplex. There are certain jobs where people need to have their hands free. They are repairing something, so they cannot be keying PTT every time they want to share something with the counterpart. So that's why we developed full duplex calls as well. TASSTA application also takes care of emergency management. So we'll see how we can set up an emergency call and how we can send our GPS coordinates. So that also takes care of about all these situations where lives can be in danger. So we deal with status messaging, text messaging as well. But now, as a difference from radio systems, we can attach multimedia files because now we have the bandwidth to do it. Of course, our application can be end-to-end encrypted for those military applications that require so. And we have dynamic group calling, which is a nice feature that allows a dispatch to reorganize how users in the field work in groups if there is a certain incident. For example, dispatcher can decide those 3 people need to work together. So the group is downloaded. Once the incident is done, that group's deleted. Everybody goes to the daily groups. So that's dynamic group calling as well. Now we are running through mission critical broadband networks, such as private LTE. So now we have the luxury to be able to use video as part of our mission critical services and guarantee that that video is coming through, which is a big difference. So we have 3 flavors of video. Individual calls, like one-to-one video calls. We have what we call push to video. So push to video is basically you press PTT. So instead of sending voice, now you're also sending video. So everybody can see what your camera, either front or back camera, is showing. So that's really useful in case of somebody requesting an evaluation of something, and so you can incorporate video into your group calls now. And we have a third flavor, which is video streaming. So there are 2 very clear examples for video streaming. So there is a user that has declared an emergency. So now dispatch can automatically start streaming or receiving the video from the user. So that's use number 1. And use number 2 is video streaming from unmanned vehicles. That means a drone that can have an Android device, attached to it, or the drone itself can be Android. So now dispatcher can decide to stream what that drone is seeing, and that it can be shared with every user in the application as well. Of course, our application deals with GPS positioning. So that's no mystery. So that's industry standard nowadays, but we have added one step more. We have using precise locations with the capabilities of 4G and 5G networks. And if we need a bit more, adding Bluetooth beacons. we are able to position users in buildings. So that means, for example, a hospital where they've got a private LTE deployment, and we can add as well Bluetooth beacons, so we can track every nurse, every doctor with an accuracy of approximately 3 meters. So that's a difference between a former situation where no doctors or nurses wanted to have a radio with them, and even if they had a radio, they couldn't be tracked in the building. So we've developed, and I think we can consider ourselves unique here, we've developed and certificate our lone worker protection feature set. So that means now the device, now the application has enough intelligence to trigger an alarm, and to trigger an emergency call if certain parameters are fulfilled. For example, no movement within a minute. So that probably is a sign that that officer is down. So now it triggers an alarm. So dispatch is going to receive an alarm, and we're going to see video, we're going to see the user in the map. And that's basically the point where I'm going to try to do a short demo. So hopefully everything is going to go right. You may hear a bit of a coupling, but I think it's worth showing this feature live. So let me show you. That's our TASSTA dispatcher. This is what you would see from a mobile device perspective. So that's the user, that's the PTT screen. So we can press PTT, and then we're talking. So of course, this application, we can change groups. That's quickly, and then we can press PTT. We have a list, of users where we see which users are offline, which users are online. We can take a user, send a message, take a picture of the remote camera, back camera. We can position the user on the map, so we can do many operations. But basically my target here is to show you how lone worker protection works. So the scenario we're going to run here from dispatch, let me put is that we're going to enable lone worker protection from user number 1. So that's my user. So let's bring this back again. So that's my user. So now I've enabled that if that user has no movement for a certain period of time, then we're going to see an alarm triggering. So that's the live demo. So now lone worker protection is enabled, and it's on. So once we see the alarm coming in, so 2 things are going to happen. So I see the alarm coming in the cell phone. Sorry, let me put you. So you see the alarm. I can cancel. It can be a false alarm. I'm not going to cancel, of course. So now you see an emergency call. Now is when the coupling starts. You see my video coming in. I can acknowledge the alarm. I can show a map. I can do many operations. But most important thing, that's me. I can be down. And then dispatcher's got a lot of situational awareness. So let me cancel this, because otherwise it's going to be a bit of a problem. So we can go into the map. We see that's where I am. We see how any one user declared an emergency. It's on red, and then the user is centered on the map as well. So this is the kind of features that encompass a mission critical application. So it's not a commercial push to talk. So we're taking a lot of care in preparing all the features that professional radio users require. So let's go back to the screen. Let me share. So that was lone worker protection feature set. Just to finalize on the features of TASSTA. So we have also end-to-end encryption, as I mentioned, authentication, and IMEI number verification. That means if somebody steals your user password, because you at the end of the day connect to a server, you can have a 2-factor authentication, because only from that device that user password will work. So this is a truly secure application. We've of course run a lot of pen testing against our application, so we can be sure that nobody can hijack or hack our servers. Briefly, and just to finalize, my part here, the TASSTA architecture. So of course we have a central server that is called T-Lion. That T-Lion can be geo-redundant with what we call T-Brother. It's the same server. They're working in hot standby redundancy, so you can have them in different data centers, for example, providing geo-redundancy to our application. Then what we call T-Flex is our mobile application, our dispatch T-Rodent that we've seen. That server is recording everything. So of course, you can have a recorded application, so you can basically download voice, video, call logs, GPS positions, you can run reports, anything that you need. And as I mentioned, we have our T-Bridge, capabilities as well for connecting to traditional land mobile radio networks. That's what we're gonna see in this slide. Depends on the technology, frankly speaking, we can offer a more intelligent or a less intelligent gateway. There are technologies, manufacturers that allowed us to develop an IP interface where we can have group calls and we can have private calls and we can have messaging. And there are other manufacturers where we just need a donor radio and we'll provide group interconnection through a 4-wire traditional analog audio gateway. So I think that was everything on specifically to TASSTA. Dean, probably you want to take care from here.
Yes, thanks, Carlos. That was great. And as on that earlier slide that Carlos was showing on architecture, keep in mind that CTS offers the TASSTA services as a managed service. So you can get started with push to talk and run it through the managed services center at CTS. And then if necessary or if desired, you can also license the TASSTA software, bring it in-house and run it on your private wireless network there. So lots of options from an architecture perspective. So some thoughts on mission critical communications and push to talk over private wireless. It has been available through the years over Wi-Fi, and interestingly and importantly, it also worked over public cellular networks. What's really powerful is when this comes together on a private network, a private LTE network or a private 5G network. This enables the local campus or communications team to control not only their network, but also their push-to-talk network. And then the push-to-talk system running on the private network, as Carlos mentioned, can interconnect with legacy LMR radios for transitional periods or for coverage in locations that don't have a private network up yet. But also, this private network implementation can also work with public networks of cellular networks. So let's say you have a communications team working on a campus environment, say they are maintenance teams, and the maintenance supervisor drives home that night. He switches his phone away from the private cellular network out to a public cellular network. And from his home, all the push-to-talk services interconnect back to his team on the private network over the public network. So all of these interconnects and intercommunication capabilities create a really powerful foundation for all types of communications, no matter what networks or what the status of your networks are at any time. So on the next slide, it kind of summarizes what land mobile radio or traditional push-to-talk over private radios would look like versus TASSTA running on a private cellular network. The key things is the amount of bandwidth that a private cellular network brings. So with video calls and video streaming, that all that opens up with private networks. And since it's a private network, it's not costing you dollars of data with a public network operator because it is your own network running in your own campus environment. And so the capabilities of private networks over traditional LMR really start opening up when you use these different features, such as video, and then combined features like drone control of your private network, combined with video streaming from that drone. And now all your people on the ground can see the camera shot from that drone. Really interesting and powerful capabilities with the additional bandwidth that a private network brings you. So on this next slide, a common question we get is, well, what devices should we use? What are we going to use for a device? Well, the good news is that TASSTA spent a lot of time making these downloadable apps compatible with all the major devices. So it'll be the Apple devices or Samsung or any of the Android devices. The application from TASSTA runs on all those devices. So these can be standard off-the-shelf phones. And starting with the iPhone 11 and the Samsung S10, those phones also provide support for the CBRS networks for private wireless. So any phone newer than that, say about a year, 2 years ago, 2019, vintage phones are compatible with the private network and then run the TASSTA software as well. And then on top of just standard run-of-the-mill phones, there are specialized, excuse me. So the Samsung phone is an interesting one. It provides.
let me help you here, Dean, if you want. So
yeah, please.
We cover. So yeah, for example, this Xcover Pro, you know, it's a military grade phone. So, you know, as Dean was saying, there are a lot of commercial devices, but, you know, there are also professional devices. So military grade, you know, it's mil specs, military specs, it's IP68, you know, it has an enhanced battery life. So no, you can run through Shift and more using, you know, background applications like TASSTA One. And it has nice features like haptics, where basically you can keep your gloves on and you can still operate with the phone in even wet conditions. So as you said, Dean, you know, everybody's asking, I mean, what is this? I mean, I can only use my device. So no, I mean, the answer is you can nowadays in 2021, you can find basically any device type, either commercial or professional, that can run on CBRS and can basically fulfill your needs. So yeah, sorry about that, but yeah, just wanted to interrupt. So
yeah, thanks, Carlos. I get so excited about that Samsung phone, it just chokes me up. So thanks for thanks for covering for me. So in a wrap up here, the TASSTA CTS partnership is multidimensional. So we provide the TASSTA capabilities within our hosted data center, and then we come together in the market to provide not only the underlying network, but all these capabilities of mission critical communications that we've been talking about here. So please look us up, contact us through TASSTA or contact us through CTS, and allow us to provide you some demos and spend more time looking at your needs for mission critical communications. Thank you very much for joining us. Have a great day.